Hi, this is Sonia Doucette. In this video, I'll show you how to find the molecular equation, the complete ionic equation, and the net ionic equation for a reaction. In this case, we're going to be dealing with precipitation reactions, but you can also do this for other reactions, such as acid-base reactions. And I'll also talk a little bit about the concept of a spectator ion. So this problem says that sodium chlorate reacts with strontium hydroxide. What is the molecular equation, complete ionic equation, and net ionic equation? So the molecular equation is going to just be an equation as you normally think of it. So you will write first the reactants. So you have sodium chlorate, and it's in solution form, so it's aqueous, plus strontium hydroxide, also in solution form. And when they react with each other, you're going to get a precipitate. You're going to get sodium hydroxide. If you go through the solubility rules, you can understand why you'll get a precipitate there. And then you'll also have left over, still in solution form, strontium chlorate. And then to balance this equation, you need to put a 2 in front of the sodium hydroxide and a 2 in front of the sodium chlorate. So that is your molecular equation. For the next one, for the complete ionic equation, all you need to do is essentially break down everything into their respective ions, keeping the subscripts and also accounting for the superscripts, and I'll show you what I mean by that in a minute, except the only thing you don't break down is any precipitate that forms. So in this case, sodium hydroxide is a precipitate. So you don't want to break that into its ions because it's a solid. It's not going to be present as ions in solution. So the complete ionic equation would be like this. You'd have 2 sodium cations plus 2 chlorates. I have a charge of -1 there. You'd have a strontium cation plus 2 hydroxide ions. So that's all of your product. And then you have 2 sodium hydroxides in solid form plus strontium cation dissolved and 2 chlorates also dissolved. So why would you want to do this? It seems to be making that molecular equation more complicated. Well, the reason is because the complete ionic equation is actually more representative of what you have in a solution. So in the solution that contains the sodium chlorate and the sodium hydroxide, what you have are really lots of cations and anions floating around in solution, interacting with the partial negative and positive ends of a water molecule if you're dealing with an aqueous solution. And all of them will be doing that except the sodium hydroxide precipitate, which will actually be in solid form sitting at the bottom of your beaker as it precipitates out. So this is your complete ionic equation. Now, to get from there to the net ionic equation, you want to eliminate the spectator ions. So spectator ions are just what they sound like. They're spectators. And what's meant by that is that they're not actually participating in the precipitation reaction that's actually happening here. So sodium hydroxide is the precipitate that forms, and it forms from the hydroxide anions and the sodium cations. So the sodium cation and the hydroxide anion reactants are actually the ones participating in the reaction. The rest of the ions are just spectators. That's one way to look at it. Another way to look at it, when you're trying to determine the spectator ions, because you want to eliminate them in order to get to your net ionic equation, is just to see if they appear on both sides of the equation and then cross them out. So let's first look at chlorate as the reactant. Chlorate appears as both a reactant and as a product. So you can cancel get rid of chlorate. It's a spectator ion. It's not going to be part of the net ionic equation. And then look at strontium, same thing. Strontium is part of the reactants and part of the products. So you can get rid of that. So what you're left with is the net ionic equation. Sodium and hydroxide are reactants that do not appear in the ion form on the product side. And sodium hydroxide solid on the product side is a solid that does not appear in solid form on the reactant side of the equation. So what you'd write then for your net ionic equation, you have 2 sodium cations plus 2 hydroxide anions, giving you 2 sodium hydroxide in solid form. And in this case, you won't always have to do this, but notice that you have a coefficient of 2 for all of your reactants and products. And whenever you're writing a balanced chemical equation, you always want to reduce the coefficients to the lowest possible whole number ratios. So you can divide all of them by 2, which will essentially eliminate them because they'll all go to 1. So the proper net ionic equation here will simply be sodium plus hydroxide, giving you a sodium hydroxide solid. So that is your net ionic equation.